Next example, finding infinite one-sided limits. As you see the picture, we are going to find the limit of the function x plus 5 divided by x plus 3 as x approaches negative 3 from the left and x approaches negative 3 from the right. You see the graph. As x approaches negative 3 from the left, the graph approaching negative infinity. Next one, the limit as x approaches negative 3 from the right, the graph approaching positive infinity. Next example, finding one-sided limits using a graph. From the provided graph, we find the limit of the function f of x as x approaches 2 from the left. Just look at, here's the x equals 2. Coming from the left, you see the graph approaching to positive infinity. As x approaching 2 from the right, the graph approaches the value 3. X approaching 4 from the left, the function approaching the value 3. As x approaching 4 from the right, the graph approaching 3 as well. Limit defined informally. If the values of f of x gets closer and closer to some number L, as values of x that are smaller than some number t, and values of x that are larger than t get closer and closer to t but not equal to t, then L is the limit of f of x as x approaches t. For a function f and a real number t, if the left-hand limit of the function f of x equals L and the right-hand limit of the function f of x equals L, where L is a real number, then the limit f of x as x approaches t equals L. This one is also called two-sided limit. We say that the limit of a function f as x approaches a real number t exists if and only if limit f of x approaches t equals L, where L is a real number. If the left-hand limit not equal to the right-hand limit, then the limit f of x as x approaches t does not exist. Limit f of x as x approaches t equals positive infinity, or the limit f of x as x approaches t equals negative infinity, then the limit f of x as x approaches t doesn't exist. Finding a limit using graph. Use the graph of y equals f of x in the figure to find the limit f of x as x approaches 3, and part B, limit f of x as x approaches 0. These two limits consider the two-sided limit. Then we don't see the superscript negative sign or positive sign. They are called two-sided limit. So we have to consider both sides of the point. Part A, limit x approaches 3 from the left, the value coming toward to the value 1, and the limit f of x as x approaches 3 from the right equals the same value 1. Therefore, the limit f of x as x approaches 3 equals 1. Part B, the limit f of x as x approaches 0, positive. Okay. So part B, limit f of x as x approaches 0, negative. Coming from the left, the value approaching 1. Which also the limit from the right, the function value approaching 1. Therefore, the two-sided limit, or the limit f of x as x approaches 0 equals 1. Or we say the limit does exist. Next one, finding a limit using a graph. Limit g of x as x approaches negative 2. You see it as x approaching negative 2 from the left and x approaches negative 2 from the right. Both directions, the function value approach the same value, which is the value 3. So the two-sided limit of the g as x approaches negative 2 equals 3. Part B, the left-hand limit of the gx as x approaches 2 as function approaching the value 2 for as x approaches 2 from the left, the function value approaches negative 1. Next example. Next example, use the graph of y equals g of x in the figure to find the following. If limits exist. Limit of the function g as x approaches negative 2 from both sides, because we don't see superscript negative sign or positive sign. So coming from both directions. From both directions, the function value approaches the value 3. Part B, the left-hand limit of the function g as x approaches 2. Coming from the left, the function value approaching negative 1. Coming from the right of the x equals 2, the function value approaches the value 0. In this case, the left-hand limit not equal to the right-hand limit. Therefore, the limit of gx as x approaches 2 does not exist.